The following content has been provided by RWTH Aachen University.
Now, what kind of knowledge is there in the world or in the head? There's two basic types. One is called declarative, and that is knowledge that tells us about facts. Right? Bonn is southeast of Aachen, or simple rules. At a red traffic light, you got to stop. Those are easy to write down, easy to put into a database, if you like, but they are actually pretty hard to learn because they don't make sense per se, right? They don't have an, oh yeah, of course. If you don't know the rule of stopping at red traffic lights, it might as well be green. Why shouldn't it, right? So you have to learn these things by heart at some point, and they only make sense, they seem to make sense once you've learned them and applied them a lot. The other type of knowledge is procedural knowledge, which is about how to do something. For example, how to play a violin. That's pretty hard to write down. In fact, you could read a book about playing a violin, and you probably still wouldn't be a very good violin player. Because some of that is subconscious, it's got to do with muscle memory, with training. It's hard to teach, much harder than teaching factual knowledge. I'm not saying that factual knowledge is easy to learn, but it's easy to teach. Procedural knowledge is hard to teach. It's best done by demonstration and training, right? If you want to learn violin playing, you probably got to get a violin teacher, and he'll have to show you the moves and guide your arm and do all these kinds of things. So what does that mean for us as interface designers? It means at least the declarative knowledge is something that we can very easily put into the world, into our design. So we can help through our design to provide the declarative knowledge, whether it's a shape of a button in affordance that's clear, or maybe even a label that tells you what to press, the numbers on a keypad. Those things are out there, and they help people. They'll still struggle enough with learning and applying procedural knowledge. Which leads to a question that kind of follows up on the very early experiments we did in the first week of how much can we remember. We already know that working memory is limited, but we basically said, oh, long-term memory, that's pretty much, open-ended. Fact is, though, if you take random, unconnected facts, you can actually remember fairly little. Your memory doesn't have a lot of capacity for stuff that is completely unexplained to it, that you cannot somehow make sense of. For example, the sequence press Control-Alt-Delete to log on that was used for a long time in Windows. That sequence doesn't make sense to anybody unless you happen to have a history of having used computers in Windows for many years before, and you knew that used to be the sequence to restart the computer. Then you're like, okay, so I'm using the restart sequence to log on. That's still crazy, but at least I remember that sequence. In fact, I had this slide up here. For years, it said, I think, Option or Control-Shift-Delete or something, and nobody recognized the mistake until somebody said, oh, actually, that's wrong. That's because it's essentially random, right? Why would it be those three keys? So how do you learn those things? You don't actually learn them per se. You learn them via associations. So via connections to things that you already know, or you try to build a mental model of it. As an example, I once had a colleague, this was in Ulm where I was working as a PhD student, and he was able to recite the first 1,000 digits of pi. That's pretty amazing if you think about it, and also incredibly useless in daily context. But it was a cool demonstration that you could do when we did this class on memory. And so he started off and he recited, and people were checking, whether he was doing it right. And the interesting thing was the kinds of mistakes he made, because he wouldn't just get a single digit wrong or something like this. He would get entire chunks wrong. And then all of a sudden he would be back on track and have it right, which is a wonderful example of how he was remembering this. He was not remembering it digit by digit. He was remembering it in groups. And then he was grouping those groups again and grouping those groups again until he had big chunks. So he was basically building a semantic tree over the actual sequence. So to give you an example, if there was he said, if there is a sequence like, I don't know, 353 in there, he would remember it as sort of a palindrome, right? It's a palindrome 353. And if it was 747, he would remember it's a plane, it's a Boeing. And so if it was, I don't know, 747, 747, he would remember it's a palindrome with 2 Boeings and a 2 in the middle, right? So he was building these semantic trees over the number sequence. And so then if you get anything wrong in one of those upper tree nodes, inner tree nodes, he would switch around the entire subtree or change it or something like that. Okay, so to give you another example, if you take if you take the who here has explained to their parents, I don't know, how to send an email or how to I don't know, send a Twitter feed or how to use FaceTime or anything like that. Yeah, we've all been there, right? Yeah, okay. It's like IT Consultants Anonymous. It's like, yeah, I've been there. And you've probably noticed if you explain to them, like you write these little cookbook recipes, right, on a piece of paper. It's like you press this button and press this button and then do this. And then there's an update to the software and the button moves somewhere else and they're lost. Because what you've given them is essentially unconnected facts. They just know, I got to press these buttons. I don't know why. If, on the other hand, you manage to, and I know this is hard with parents, so I understand if you can't get there, but if you manage to explain the conceptual model to them somehow of what's going on, then they will be able to address changes in the interface themselves and be able to understand what they're doing and will not get lost as quickly. So that's when you move from random unconnected facts to connected facts, where you use associations in order to make sense of stuff. We already talked about the bike directional indicator last time when we talked about mappings, right? The moment that somebody explained to this guy that you simply push the indicator in the same direction that you move your motorbike handle as you turn around a corner, he would never again forget what the mapping was. But before that, the mapping was random, and he had to actually memorize it as an unconnected, unexplained fact. And then finally, if you have stuff that is explained to you that you can understand, you can remember a lot. Because at that point, a conceptual model emerges in your head. And you can reconstruct that model if needed. Nobody needs to explain to you how the number system works, because you've understood how numbers work, how adding and subtracting works, and that kind of stuff. This is also very valuable in new situations when your recipe that you remembered fails. Coming back to the example of your parents sending email, when the recipe fails and they have a conceptual model of what's going on, then that will help. So, quick exercise. This won't take long. How many online accounts with passwords do you have? Just try to, very, very roughly guess it. Let's hear 10 numbers here. Let's just see. 274. That's a bit scary that you know that number, but okay. Okay, that's why you know it. Good. Which we'll get to the next question. So 2 to 300. Does that feel roughly familiar? Yeah, we're probably all in the hundreds at this point, right? Question number 2 is, how many of these can you, off the top of your head, unless you're using a password manager, can you, off the top of your head, remember your password to? So when you have to log onto that website, you're not using the autofill, you're actually typing in your password. Think about this for yourself. Probably not all 2 or 300, right? What do you think? 5 to 10, right? Okay. And then, of course, the scary question, don't tell this to Ulrike Meyer, our security professor, she will go crazy. How many of those use the same password? None, of course, because we're all good citizens, right? And the point here is that especially security poses a major usability issue, right? When you try to make a system secure, you are very quickly touching on usability issues, right? It's almost impossible to keep usability at a high level without, when you want to address security. So this is a very tough design challenge. And password managers, for example, are one way out of this, right? Then you basically put your knowledge in the world. You put your password somewhere else in a hopefully secure encrypted database that nobody can get their hands on except the NSA and Apple and Google. And then from there on, you can use those secure passwords auto-filled from that application. And that's just online accounts, right? Now think about it. You've got credit cards or cash cards with PINs. You've got accounts with your bank routing number, or these days you've got an IBAN. You got number plates. You got phone numbers and addresses of birthdays and ages of friends. You got clothing sizes. And thank God we all have a smartphone, right, that remembers most of that stuff for us. Because a lot of that stuff you will not remember. Fantastic example, by the way. The move from, this is not in the slides, but I think it's a wonderful example because it just happened recently. The move from the bank account and routing number, or Bankleitzahl in German, to the IBAN system. Give me a quick, inspired by DIS1, analysis of the usability impact. Yes? Yes?
I think it's, although it's just a combination of the two with the check number, I think it's way more complicated because there's like 20 digits and you can't remember them in whole. And it's, even if you know the numbers, it's difficult to recheck when you put it in because you don't have these marks, okay, the first 8 and then the next 8. Absolutely.
So technical information, this was right, is important to understand. The IBAN, of course, is just your bank code and the routing number together, and there's 2 more digits for the checksum that makes sure that you don't make a mistake, which is a great design, and then there's 2 letters for the country code, right? So, which is always DE, so that's easy. But because, and when you look at the old bank code and routing number, those were usually numbers that were what, like 7, 8 digits, somewhere on that line. So those you could actually, we know from the first class, easy to keep in working memory. Like it's a nice, comfortable chunk that you can hold on to. You almost have a little song in your head when you go through, oh, my bank number is right? That doesn't work with 22 digits, like you get lost, right? So the fact that they get strung together with lots of padded zeros in the middle, which is probably the hardest part of all, right? How many zeros go in between? That makes it difficult to remember these things, much more difficult than the old bank code and rounding number. Also, quite a few fields will not accept you typing it in pairs of 4, right? There's a human readable format which has 4 digits at a time and then a gap and then 4 digits at a time, which makes it a little easier to parse and not get lost. But a lot of fields will not accept you typing in those spaces. That is bad interface design. Even if you take the badly designed IBAN, instead of the old bank code and routing number, if you don't let the user type in those spaces to help them chunk the information and control visually whether they made a mistake, then that would be a bad user interface. Anyway, and of course, as the interesting thing is, the harder the password requirements become, often on websites. IT departments love putting up crazy password requests. Like you have to have an upper letter and a lowercase letter and a number and some kind of like non-alphanumeric letter and then probably some Cyrillic characters or whatever. And it has to be at least 43 characters. The system becomes less secure in a sense, right? Because people will start making up stupid stuff and go like, okay, I'm going to put all dots and all ones or whatever, and then maybe an A at the end just to fulfill all these stupid requirements. We tend to move these things from the head into the world. That's what password managers, for example, then do, or where we store all these things in our, whatever, smartphones and in calendars and notebooks. So if you look at the knowledge in the world and knowledge in the head and reflect on this, knowing that there's these different types, knowledge in the world is great. There's nothing to remember, but you only see it, or you only know it while it's there. If it's gone, out of sight, out of mind, so to say. Especially difficult with things that are not very important to you. The solution, of course, for these things are reminders, right? So when you set your smartphone, or when you write down a reminder, remember to call your mom, on her birthday. That's where you put it out in the world. And of course, that's only part of the solution because that means you need to actually look at that paper calendar at the right point in time to do that, to place that call. That's why, of course, PDAs or smartphones, whatever you have, your laptop, then have a little beep beep signal telling you that something's going on. And oftentimes, I don't know about you, but when my alarm goes off to remind me of something, I don't even need to look at the message. But the moment it goes off and just says, remember there was something, I hear the alarm and I'm like, oh yeah, right, I need to call this person. Right? So sometimes the trigger is enough to give me back the message. And other times I need to look, okay, what is it trying to remind me of? Oh yeah, right, it's this appointment or this thing. If you've ever heard about getting things done, it's a productivity technique that some people are crazy about, especially computer scientists seem to like it a lot. It's all about externalizing knowledge, right? Putting all these things out in lists in the world. So if we compare this knowledge in the world and in the head with each other, it basically means knowledge in the world, available as soon as visible, you don't need to learn it. The efficiency is pretty low because you need to interpret, you need to look at the keys when you type, for example. The initial usability, however, is high because I don't need to learn typing. I can start typing on the keyboard immediately. If there is a lot of knowledge in the world to display, however, aesthetics, just how it looks gets a little yucky, right? There's a lot of labeling there. Knowledge in the head, on the other hand, is not as available as in the world, and is not as suitable for beginners, harder to learn, but it can be very efficient. Like we said, typing when you know the keyboard is much faster. You're recalling the typing layout from your brain, from your memory, and apply it as you go. And it is invisible in the sense that it doesn't clutter your interface, right? It doesn't put stuff there. Remember, however, that sometimes this seems like it's a contradiction. You got to go this way or this way, and both have their disadvantages. Sometimes you can actually get out of this pinch, because if you apply a natural mapping, if you use affordance as well, if you use a design that automatically explains itself simply by its design, you can get out of those things. You don't need to label stuff, and you can save people the learning curve, right? So if there is, I don't know, 2 lamps and then there's 2 buttons, then it's going to be clear which way the mapping works.
This content was provided by RWTH Aachen University.